All right, pre-algebra, this is chapter 8. We're only going to do the first 4 in chapter 8, so let's take a look at 8.1. I'm on page 489. All right, so first off, vocabulary, order of magnitude. Order of magnitude means that you put it's on here. I'm just going to read it to you. On page 491, it says about halfway through, highlighted. The order of magnitude of a quantity can be defined as the power of 10 nearest the quantity. Order of magnitude can be used to estimate or perform rough calculations. For instance, there's about 91,000 species of insects in the United States. The power of 10 closest to 91,000 is 10 to the 5th, or 100,000. So there's about 10 to the 5th species of insects in the United States. So it's used to estimate. Let's write that first. Using powers of 10. So 91,000 is about 10 to the 5th, which is 100,000. Okay, and we'll talk about that. I believe there's going to be one here maybe a little later. It's just nice. That's one of those things that you might just go, oh, I've seen that before. All right? Okay, power. We've talked about, actually, I think I'll just write an example. Let's do 3 to the 4th. This whole thing is called a power. The exponent is this little dude right there, and the base is this number right here. So a power shows us, the exponent tells us how many times to multiply the base times itself. So it's 3 times 3 times 3 times 3, and you've been doing that for a long time, so you should have that pretty straight. So let's do the first key concept box is the product of powers property. So let A be a real number, let M and N be positive integers. To multiply powers having the same base, you add their exponents. So algebra would be A to the M times A to the N equals A to the M plus N. All you do is add the exponents. So our with numbers, it would be 5 to the 6th times 5 to the 3rd equals 5 to the 9th. So you just add but the bases have to be the same. So let's take a look at these. Ooh, the answer's already there. So 7 to the 3rd times 7 to the 5th, since they have the same bases, you can add the exponents, and you get 7 to the 8th. And I think on this I want to, I want to see that you know how to do that. So just leave it 7 to the 8th. Don't do that one out. So when there isn't anything, you see this 9, there's not a number written, and there's still a 9 there, so that's like 9 to the 1st. And they show it over here. So all of those bases are the same, so you add them all up. And actually you can look at it this way, how many 9s are there? There's 1 there, there's 8 there, there's 2 there, for a total of 11. So 9 to the 11th. These have negative bases. This is that unwritten 1 right there, so that'll be to 5 to the 7th. So the bases are the same. You add the exponents. Same thing with letters. The letters and the bases are the same. You add the exponents. So this is going to be, base is the same, 3 to the 9th. Done. This one's going to be 5 to the 10th, because that invisible 1. This one's going to be negative 7 to the 3rd. There we go. And this is, there's 1 there, so 6, 7, x to the 9th. So pretty fast, okay? That's it on that one. All right, our next key concept box is the power of a power. So let A be a real number, let M and N be positive integers. To find the power of a power, you multiply the exponents. So that example looks like this. A to the M to the N equals A M times N. Now see the difference here. This is a power raised to another power. So 3 to the 4th to the 2nd is 3 to the 8th. You just multiply them. So that's just going to be 2 to the 15th. Okay, this one's going to be negative 6 to the 10th. And you should leave the parentheses around it. This is just x to the 8th. And this everything is just, since there's parentheses, it'll be y plus 2 to the 12th. So this is going to be 4 to the 14th. This one's negative 2 to the 20th. Almost seems too easy, doesn't it? This is n to the 18th. And this is m plus 1 to the 20th. All right, another key concept box. Here we go. We're plugging along, it seems like. It says the power of a product. So to find the power of a product, you find the power of each factor and multiply. So this one has inside, notice, ab to the m. So that means a is to the m power and b is to the m power. So that is a to the m times b to the m. So you're just taking the power and you're applying it to each factor inside the parentheses. So the next one with a number would be 23 times 17 to the 5th power. It's kind of like the distributive property if you think about it. So it's going to be 23 to the 5th times 17 to the 5th. So this one's going to be 24 to the 8th times 13 to the 8th. And this one you just take everything. It's going to be 9 to the 2nd, x to the 2nd, y to the 2nd. It's like distributing that second into the whole thing. And then they simplified the 9, get rid of the times in between, try to make it as simple as possible. So this one will be negative 4 to the 2nd, z to the 2nd. Negative 4 to the 2nd means negative 4 times negative 4, which is positive 16. Now this one, look, it's the only thing that's different is the negative is on the outside, so that means it's not attached to that exponent at all. So it just kind of hangs, it means this whole thing is negative. So it just hangs along, and then this exponent's going to go to the 4, this one's going to go to the z. Now it's 4 squared, which is 16, and in this case, since the negative was not squared, it's still a part of the problem. So the answer is negative 16 z squared. So this one, it's got all three properties in it. What I would do is I see this power to the power right here. Inside there's two factors. So that's going to be 2 squared times x to the 6th times x to the 4th. Now I see that 2 squared is 4. I can do that. X squared, or x to the 6th and x to the 4th, make x to the 10th. And then I'm done. And they might do it a little different, but it should all come out the same in the end. And you just got to remember when you add them and when you multiply them, it gets a little tricky. All right, example number 5, bees. In 2003, the U.S. Department of Agriculture, the USDA, collected data on about 10 to the 3rd honeybee colonies. There are about 10 to the 4th bees in an average colony during honey production season. About how many bees were in the USDA study? So you just multiply them. So that'll be 10 to the 7th, which is a 1, 2, 3, 4, 5, 6, 7 zeros. 10 million bees, 10 to the 7th. You just multiply them. All right, so simplify the expression. This one would be 42 squared times 12 squared. And I don't think, yep, that's how they want it. Oh, let me erase, sorry. This is going to be negative 3 squared times n squared. Negative 3 times positive 9n squared. So I'm going to go 9 to the 4th, m to the 12th, because I got to multiply those together, and n to the 4th. 9 to the 4th, I don't know what that is. 6,561 it looks like. And then those are, we agree. So let's see, 5 times 5 to the 4th times x to the 8th, multiply right here. That'll be 5 to the 5th times x to the 8th. That's 125 x to the 8th. I think no, I didn't do that right. That's not 5 times 5 times 5 times 5 times 5. I didn't do enough. 5 to the 5th. I'm not doing very well with my exponents. Let me get my calculator. 5 to the 5th. That was 5 times 3, not 5 times 5 times 5. All right, what if in example 5, 10 to the 2nd honeybee colonies in the study were located in Idaho? About how many bees were studied in Idaho? So there was what, 10 to the 3rd number of bees in each colony? So 10 to the 3rd times 10 to the 5th, I believe. 10 to the 2nd, I mean, it's 10 to the 5th. 1, 2, 3, 4, 5. 100,000? Where did I mess up? Hold on. About a million. 10 to the 2nd. Oh, there's 10 to the 4th bees per each colony. Sorry. Times 10 to the 2nd would be 10 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. That's what's cool about 10 to the 100 million bees. We still have a million. Where am I messing up? Oh, you guys, look what I did. I multiplied. The bases were the same. What am I supposed to do with these? I'm supposed to add the exponents. See, it's hard to keep track, so I can't even do it. Good luck. That would be a million. All right. Whoosh. Okay, I think that's it. Have fun with all those properties and be careful with the negatives.